Europa is one of the most important scientific targets in the solar system. Its subsurface ocean might be home to extraterrestrial life, and studying Europa could help us better understand the formation and evolution of planets. Therefore, landing a spacecraft or even sending humans to Europa is of great interest to scientists. But is landing on Europa feasible? And what challenges must we overcome to achieve this mission? Let's explore these questions in today's video by Wisdomwave Universe. Europa, also known as Jupiter's Aku, is the sixth moon from Jupiter, counting from the inside out. It was discovered by Galileo Galilei and Simon Marius in 1610. Among the four large moons of Jupiter discovered in 1610, Europa is the smallest. Europa has a diameter of 3,100 kilometers, slightly smaller than Earth's moon. Europa has been studied by many spacecraft, including Voyager 1 and Voyager 2 in the early 1980s, Galileo in the 1990s, and Juno in the 2010s. These spacecraft have photographed Europa's surface, measured its gravity and magnetic field, and searched for evidence of subsurface oceans. Landing on Europa is not impossible, but it will be very challenging. Firstly, the ice surface. Europa is covered by a thick ice layer, estimated to be up to 100 kilometers thick. This ice surface has many cracks and ridges, believed to be caused by the movement of subsurface ice. Secondly, the subsurface ocean. Beneath Europa's thick ice layer, it is believed there is a subsurface ocean containing more water than all of Earth's oceans combined. This ocean is thought to be a potential habitat for extraterrestrial life. Thirdly, gravity. Europa has a gravitational force about 2 times weaker than Earth's. This means if you were on Europa, you could jump much higher than on Earth. Fourthly, the magnetic field. Europa has a weak magnetic field, believed to be caused by the movement of electrically conductive ice beneath the surface. Fifthly, the distance. Europa is on average about 630 million kilometers from Earth, meaning it would take at least 3 years to get there with current technology. That's a long time to spend in space, especially for humans who need food, water, oxygen, and protection from cosmic radiation and microgravity. A human mission to Europa would require a lot of resources, planning, and innovation to ensure safety and success. Sixthly, radiation. Europa is exposed to intense radiation from Jupiter's strong magnetic field, which can damage electronics and living cells. Europa receives 5.4 sieverts, 540 rem, of radiation per day, about 1,800 times the average annual dose for humans on Earth. A person exposed to this level of radiation for 1 day would have over a 50% chance of dying within a month. A spacecraft or lander to Europa would need a lot of shielding and hardening to survive the radiation. Seventhly, temperature. Europa has a very low surface temperature, around -183 degrees Celsius, colder than Antarctica. A spacecraft or lander to Europa would need a lot of insulation and heating to keep its equipment and systems functioning normally. A person on Europa would need a special suit to stay warm and prevent frostbite. Landing a spacecraft on Europa is an incredibly challenging task, but it is also a scientifically valuable one. Europa's subsurface ocean is one of the most promising places in the solar system to search for extraterrestrial life. By sending a lander to Europa, we could directly sample this ocean and search for signs of life. However, the challenges of landing on Europa are immense. The surface is extremely cold and irradiated, and the moon's gravity is weak. Any lander would need to be able to withstand these harsh conditions and land safely on the surface. Once on the surface, the lander would need to be able to power itself and communicate with Earth. It would also need to be able to melt through the ice and explore the subsurface ocean. Despite the challenges, there are a number of concepts for Europa landers that are being studied by scientists and engineers. These concepts include landers that would land on the surface, and then use robotic arms to drill into the ice, as well as landers that would melt their way into the ice using heat. There are also concepts for landers that would use buoyancy to float on the subsurface ocean. The first mission to land on Europa is likely to be a decade or more away, but the potential rewards are great. Landing on Europa would be a major milestone in our exploration of the solar system and could lead to the discovery of life beyond Earth. In addition to the challenges I have mentioned, there are also a number of ethical considerations that will need to be addressed before a mission to Europa can be sent. For example, we will need to make sure that any lander does not contaminate Europa's subsurface ocean with Earth life. We will also need to consider the impact that a lander could have on Europa's environment. Despite the challenges and risks, I believe that landing on Europa is a goal that we should strive for. It is an opportunity to make a truly profound discovery that could change our understanding of the universe.